For 800 years, the Reykjanes Peninsula was silent. It was a place where thick moss grew over ancient jagged lava fields, where fishing towns were slowly built on the coast, and where modern civilization flourished in complete safety. To the people living there, the solid earth beneath their feet was a guarantee. But that safety was an illusion. In March 2021, the silence broke. Deep in the valley of Grindavík, the earth tore open, but it was in late 2023 and early 2024 that the true scale of the threat revealed itself. The ground beneath the town of Grindavík didn't just shake, it hemorrhaged. Magma that had been accumulating for centuries punched through the crust, creating fissures that ripped through roads and homes and sending fountains of fire soaring into the dark winter sky. Most news outlets treated these eruptions as individual disaster events, singular tragedies to be reported and forgotten. But they missed the bigger picture. This isn't just a natural disaster. It is the opening salvo of a geological war. Geologists and volcanologists now confirm that Iceland has crossed a terrifying threshold. The peninsula hasn't just experienced an eruption, it has entered a new eruptive era. We are looking at a cycle of violence that will likely last for the next 200 to 400 years. The question isn't whether the volcanoes will erupt again. The question is, can a modern, technologically advanced society survive a siege that will last for centuries? This is the story of the most ambitious engineering experiment on Earth, humans versus the planet itself. Before we dive deeper beneath the crust, look down. If that subscribe button is still red, crush it right now. We explore the Earth's most dangerous secrets every day, and you don't want the algorithm to bury the next discovery. To understand why this is happening now, and why it won't stop, we have to look miles beneath the surface. Iceland is a geological anomaly. By all conventional laws of tectonics, this island shouldn't exist. Most land on Earth sits on thick, stable continental plates, but Iceland sits directly atop the mid-Atlantic ridge. This is the jagged scar running down the center of the Atlantic Ocean where the North American and Eurasian tectonic plates are actively ripping apart. Usually this process, known as rifting, happens deep underwater, quietly birthing new ocean floor in the crushing darkness of the deep sea. But Iceland has a second, more volatile ingredient, a mantle plume. Think of a mantle plume as a blowtorch aimed at the crust from the Earth's core. It is a column of superheated rock rising through the mantle, melting as it decompresses near the surface. Iceland sits exactly where these two titanic forces intersect. The ridge pulls the crust open like a zipper, and the hot spot floods the gap with massive amounts of molten rock. This combination creates a geological sweet spot that produces more magma than almost anywhere else on the planet. It is the only place on Earth where a mid-ocean ridge rises above the waves to be inhabited by humans. For the last millennium, the tectonic stress here has been building up. The plates have been drifting apart at a rate of about 2 centimeters per year. That might sound slow, but over 800 years, that creates nearly 20 meters of stretch, 20 meters of missing land that the Earth needs to fill. Now, the crust is snapping back to fill that void. Volcanoes are often portrayed as unpredictable beasts, but on the Reykjanes Peninsula, they follow a hauntingly precise rhythm. By analyzing ancient ash layers, using a technique called T-fracronology, and cross-referencing them with the saga records of the Vikings, scientists have reconstructed a timeline that goes back thousands of years. The pattern is undeniable. The peninsula operates on a cycle of roughly 800 to 1,000 years. It creates a pulse of activity that defines the history of the island. The cycle works like a capacitor. You get a period of rifting and intense eruptions that lasts for 2 or 3 centuries, known as the fires. Then the tension is finally released, the magma chambers solidify, and the land goes dormant for the next 8 centuries. The last cycle, known as the Reykjanes fires, began in the 13th century. It was a catastrophe for the medieval inhabitants. The skies turned black, livestock died from fluoride poisoning, and the very shape of the coastline was altered. But the Vikings had no way to fight back. They could only flee or perish. When the fires finally died down around the year 1240, the peninsula went to sleep. That long sleep allowed us to become complacent. During those 8 centuries of quiet, Iceland transformed from a poor farming society into a high-tech Nordic nation. We built the Keflavik International Airport, the world-famous Blue Lagoon, massive geothermal power plants, and entire towns directly on top of the dormant fissures. We treated the land as solid, forgetting that in geological time, 800 years is just a blink of an eye. The eruptions that began in 2021 were the alarm clock ringing. The dormant period is over. The new fires have begun, and if history is our guide, they won't stop until the year 2030 or 2040. This brings us to the unique situation we find ourselves in today. This is the first time in human history that a high-tech civilization has faced the onset of a centuries-long volcanic cycle. And unlike the medieval farmers, modern Iceland isn't just running away. They are trying to engineer their way through it. The war is being fought on two fronts. The first is information. The entire peninsula has been wired with one of the most advanced monitoring networks in the world. Using satellite radar interferometry and GPS stations anchored deep into the bedrock, scientists can measure the ground inflating by mere millimeters. It works like a breathing lung. As magma rises from deep below, it accumulates in a sill, pushing the ground up. When the pressure becomes too great, the rock fractures, and a vertical sheet of magma, called a dike, shoots toward the surface. Scientists can watch this happen on their screens. They can literally track the magma tunneling through the crust in real time, predicting where the ground will crack open hours or even days before the first lava appears. But prediction is passive. The second front is active defense. When it became clear that lava threatened the Svartsengi geothermal power plant, a critical facility that provides heat and hot water to 30,000 people, the authorities authorized a radical plan. They mobilized the country's largest fleet of heavy machinery. Day and night, bulldozers and excavators piled up thousands of tons of rock and soil. These aren't just piles of dirt. They are carefully engineered berms, kilometers long and standing 2 stories high. The design is based on complex fluid dynamic simulations. The goal isn't to stop the lava. Physics makes that impossible. You cannot stop a river of molten rock that weighs millions of tons. The goal is to deflect it. By angling the barriers, engineers force the lava to flow sideways, steering it into uninhabited valleys and away from critical infrastructure. In recent eruptions, this strategy was tested by fire. We saw lava pile up against these walls, consuming the barrier itself, but flowing around the power plant. It is a desperate, tactical form of civil engineering, redesigning the landscape while the volcano is actively trying to destroy it. However, this war has clear, painful limits. The events in the town of Grindavík showed us the cold reality of geology. You can divert a surface lava flow, but you cannot stop the ground itself from tearing apart. The magma intrusion beneath Grindavík didn't just threaten to erupt, it physically stretched the town. Fissures opened up in the middle of streets, houses were pulled apart from their foundations. This scenario represents the worst case that no wall can fix. When the earth opens up beneath your feet, engineering fails. This has forced a profound psychological and strategic shift in Iceland. The strategy is moving from protection to adaptation. It means acknowledging that some land is simply lost to the cycle. The country is now redesigning its entire infrastructure approach for a 400-year timeline. They are laying redundant power lines so that if one is severed by lava, another takes over. They are protecting underground pipes with lava-proof casings and deep burial techniques. They are discussing the creation of mobile utility networks that can be moved if the ground begins to swell. They are even using artificial intelligence to run thousands of eruption scenarios, calculating exactly which roads will be cut off first and where new harbors might need to be built if the coastline changes. They are preparing for a future where an eruption isn't a rare, once-in-a-lifetime catastrophe, but a seasonal weather event, something to be managed, mitigated, and endured. What is happening in Iceland is more than just a local news story. It is a preview of our relationship with a volatile planet. We often think of the Earth as a static backdrop for human history, a solid stage that we build upon. But the Reykjanes Peninsula proves that the stage is alive, and it moves to its own rhythm. Iceland is currently running a real-time experiment. Can human ingenuity outpace geological time? Can we coexist with the raw power of a mid-ocean ridge for 4 centuries? There is no winning this war. The volcano will eventually do what it wants, but through science, engineering, and sheer resilience, Iceland is attempting to negotiate the terms of surrender. They are showing the world that while we cannot conquer nature, we might just be smart enough to survive it. If you want to keep exploring the edges of science, engineering, and the future of our planet, make sure to hit that subscribe button and turn on notifications. The world is changing fast, and you won't want to miss what comes next.